perspective. The cerebellum doesn't play much of a role. So it's localized in parts of the cerebellum. That seems to be the possible theory. We're not yet in a position where we can answer that question, but it does seem to me, an intelligent question, because if I'm right in thinking that it's caused by brain processes and realize in the brain, where exactly in the brain? And there has to be an answer to that. I don't know the answer to it. I don't know that anybody else does. But it seems to be quite likely that we'll find that some parts of the brain are much more simple than other parts.
Yeah, so that's the question of, I mean, that's the NCC program, right? Which part of the brain are causally relevant, but that seems to be slightly different what may be intended by the question, because people often seem to me that seem to want to know does it have a particular location in space? And it doesn't have a particular location in space. It's created by an organ or by particular components of this organ, but it doesn't have any particular location in space, except that you can point at this part of that part of that part of the brain that's responsible for actually generating it.
I think space is the creation of planet.
Wow. I don't think we want to talk about space and but the discussion we're having here is an echo of an old discussion, and it's about the location of the soul. The soul is not a spatial entity, but if it exists at all, then it's got to be somewhere. And it's either on the left side or the right side. If it's on the left side, it's at the bottom half of the top half, and then it looks like you're going to have to be able to locate where the damn soul is. Now, this is one of the many problems with the notion of the soul. I think as we get a better understanding of how the brain uses consciousness, the question of the spatial, the question of the actual specificity of certain sub-organs of the brain with specific spatial location is going to become crucial.
Yeah, so I think ultimately it's going to reduce to the question, what is the specific spatial temporal causal mechanism? Yeah. You have a network of causally interacting parts, and I think the question is what is the nature of this specific causal mechanism that gives rise to conscious sensation? Why here, why not in my liver, or in my immune system, or in my intelligence system?
Well, one more comment on that, because I agree that's a very fuzzy concept, local and non-local. One of the ways it's often brought up in discussions of consciousness is like some of the data that you referred to in your lecture. Things like, say, remote healing, or other kinds of long-distance interactions between humans that are claimed to exist. Now, it's very convenient for mainstream science to sweep all that stuff under the carpet because it doesn't fit with the conventional view. But if you take that data seriously, then that suggests that maybe something is going on which is a little less local than simply tied to individual brains. And I don't know. I first admit I don't have a clue what's going on. However, I have taken that data seriously. I spent a lot of time looking into it, and it seems to be reliably collected stuff. So somehow in our expanded definitions of consciousness, it may be useful to take a look at that.
Okay. So I guess this was related to what was talked about, but complex biological structures and systems, such as the cerebellum and the autonomic nervous system, are made of neurons, process information, and generate complex behavior. And yet, they are not necessarily conscious. What distinguishing physical property allows one system to sustain consciousness while the other does not?
So the best evidence we have, if we look at, for example, John just made the point about the cerebellum not being involved, and 8% of our brain cells are cerebellar neurons. The complexity of cerebellum is much simpler. They're essentially, if you look at the connectivity and the geometry of them, they're essentially they're organized in two-dimensional sheets. While cortex has a small road connectivity, it's organized in 3D. So if you use metrics of complexity, cortex, the cerebral cortex, is vastly. I think that's a critical key in terms of the complexity of these tissues are simply not comparable. They're both made out of neurons, but the complexity is vastly different.
I think it might be a level thing. We've sort of adopted the neuronal hypothesis as somehow being necessarily correct for, well, certainly for behavior, a lot of mental events, and so on. We can see the connections, but that might be the wrong level in the neural hierarchy or the fractal hierarchy of the brain. If you go down a level, the sizes become very small, so the size of the synapse around, at that level you're going to get quantum effects, so you're going to be, classical mechanics isn't going to be adequate for trying to capture what it is that's happening in the brain at that level. The microtubules around particular structures in the brain and so on appear to be processing information as well. We're learning more about the ways in which astrocytes process information. I'm not convinced that consciousness is necessarily tied to neuronal activity. I think that we might need to go down a level in this fractal hierarchy to see where those connections exist. I'm not sure.
Well, I mean, one fact we do know, if your EEG goes flat, you're either in coma or in persistent vegetative state or dead. That's an empirical observation.
Yes, and there's a procedure called hypothermic cardiac arrest, in which you actually drain the blood from a person, lower their temperature, drain the blood out, and so on, in order to correct aneurysms in the brain. There are 2 cases now at Phoenix, where during the time of the surgery, and these people have EEGs that are flat, where they report subsequently events that occurred in the operating theater that they have no business reporting because those events occurred at the time when there wasn't an EEG. That's reasonably reliable data from the neurosurgeons who were in those operating theaters.
Yeah, I mean, I've yet to see any reliable sort of repetition of these. I mean, that's the trouble with anecdotes. That's exactly the difference between science and anecdotes, right? Yeah, we can all tell us an anecdote, and I'm not doubting that the surgeons said what he said, but that's very different from a carefully controlled experiment where you rule out, other sources of contamination, like the nurse talking to the patient afterwards, and the patient is remembering, right? We all know from 100 years of psychology, you can't really, when you ask people, you have to be very, very careful because people have all sorts of beliefs about what they saw. They have very powerful beliefs what they remember, but you can show under careful controlled condition that it's also induced by other factors, right? That's why you need, that's why you need to do empirical tests to verify all of that. And I don't know of any such successful tests. And furthermore, I don't know of any mechanism how this would work.
Yeah, I can't agree with you more. And when we try to get into, they do a hypothermic cardiac arrest at the University Hospital, at the university they're working, they wouldn't let us near the patients. We wanted to do pre and post measures on them to see whether they had near-death experiences, if so, what occurred during those near-death experiences, and to try to get exactly the kind of data that you say is necessary, but unfortunately, we can't get near them. Bruce Grayson, who has tried to do the same research, professor of psychiatry at the University of Virginia, was also denied access. Now, the latest I heard from him may be able to get access to some of these patients.
Yeah, I just want to again reinforce the importance of careful experiments there. And I spent several months, a couple of years ago, at the University of Virginia working in Bruce Grayson's group. And these are serious scientists. And this guy has tracked more than 1,000 patients that had life-changing near-death experiences at some point over the last 3 decades. And so this, yes, each one is an anecdote, but now we have many hundreds of cases that have been carefully studied of all kinds of strange things happening when somebody is supposed to be dead. To me, this is like the richest source of material, one of the richest sources of material to potentially take us to the next level of really understanding something major about how the brain and the mind are influencing each other in these situations. But good science has to be done continuously.
Okay, so one experiment and one comment. So I don't doubt the validity of the perceptual experience of near-death experiences. Oscar Wilde said somewhere, you can't argue with perception. People have this perception. I don't assume they're lying in their studies. I do believe they have this interpretation. Imagine now, if we couldn't dream at all, only once in your life you would dream, right? What would our life be like? Right? You never dream, you just go to sleep and you wake up in the between this blank. But then once in life, through some aberration in your brain, you actually dream, right? You dream that last night I flew around and I met my dog, my dog that died 10 years ago, my beloved nose, right? So if you only had this once a dream, it would be so extraordinary, we would spin all these yarns about this other world, and I fly at night, this one event, special event, God touched me and I flew into this other reality. But since we all dream every night, we get used to it. We see animals dream, you know, if you have a dog, you can see sort of it's chasing in its dream. So we get used to it, we accept it as part of our natural experience. But near-death experience, because it happens so rarely, we suddenly accord this very different metaphysical interpretation. Now, there was a study done that couldn't be done today anymore, that was done on recruits, on Navy recruits, who quote-unquote had volunteered for it in 1943. The US Navy recruited 2,000 young men at the age of 19 to 21. They wanted to know how long this is a real study, they wanted to know how long does it take for people to be unconscious if you choke them. It's a real study, it's published, I can give you the reference, it's in my book. So it turned out the average healthy American male takes 7 seconds. Okay, so you choke them after 7 seconds, you know, the brain automatically shuts down and then it wakes up again. Some of these people reported when they woke up again intense hallucinatory experiences, very, very intense experiences. Similar, if you take some test pilot and you spin them at 7G, you know, till they faint, sometimes when they wake up, because now the brain wakes up at different points in time, different parts of the brain go online at different times. They're really very, very intense experiences. Now, if you're a healthy 19-year-old male, you're concerned about other things than death. You know, you're concerned with girls and drinking and stuff like that. So people don't really report religious experiences, right? But when you're now 85, fast forward, you know, you're 85 now you have this experience, and of course, very often, you're much more likely to give it a very, very different interpretation, and suddenly the metaphysics all changes.
Well, I'll say something about this. It's interesting, if you live long enough, the scientific anecdotage recurs. In my childhood, there was a guy, I think most of you probably never heard of him, called J.B. Ryan, who did scientific, in quotes, studies of extrasensory perception at Duke University.